I mean, you're obviously a very innovative business, and innovation's got a central role to play in solving the climate change and energy crisis. How do you see yourselves over time? I know you're sort of pre-production at the minute, but are you intending to have an ongoing programme of innovation and improvement?
Yes, for sure. I mean, what we see is we get the first commercial product into the market, and then we will continue to evolve and improve that product, you know, making it more efficient so we can generate more electricity per square metre by improving the longevity of the product. So very much, I guess my analogy, we were like Windows when that came to market, Windows 1 compared to where we are now, Windows 11. There's a lot of development go on that forward. So that's on one area. But on a second axis, what's interesting is the underlying architecture that's in this film. So what we've got in this one is we've got something like 80,000 microstructures in this small piece I'm holding in my hand. Right. We can actually use those microstructures for other applications. Right. So we've got some applications in the field of sensing, in particular things like hydrogen sensors, touch screens, and a number of other applications. So Parallel will continue to have an R&D centre here in County Durham, right. Which will be the hub of that technology, and then we'll be working with companies around the world to bring these next generation products to market, because solar generation is one element, hydrogen's another, and there are many other streams that we can drive our technologies into. So it's going to be a continuous innovation journey, and you know that's very exciting for us. That it's developed here in the northeast, and hopefully scaled around the world. Yeah,
and so with that innovation and the novelty of your products, you've already got a significant patent portfolio. So can you tell us a bit about the challenges you faced in sort of pursuing that, and how you think that could help the business going forwards in terms of the licensing model and other aspects?
Yeah, for sure, Helen. We've invested very heavily in setting up our patent portfolio, and we've got around about 22 patent families granted in over 80 countries around the world. So one of the first challenges that comes with that is cost, which can't be avoided. But we work in an effective manner to cover those territories where we think there's most value. You can't cover everything everywhere, and we've deliberately split up our IP into different families, so we don't have to take everything everywhere. We can take certain amounts everywhere. So, but obviously for us as a company, that IP and those patents are super important. Because they protect the underlying architecture behind what we're doing. Yeah. But on top of that, and possibly even more valuable, is the know-how. Yeah. So we've got a lot of know-how that we capture on top of those patents that we only disclose to our licensing partners and others, and they really provide the barriers to entry. But for certainly like investors and other third parties working with us, they want to make sure that the technology is protected for as long a period as we can. And so we're continuously looking to file new pieces of important patents. We've just filed some patents relatively recently, and what was interesting, because this technology is so different to everything else out there, that the only patents that were cited against ourselves were our previous patents. Right. So it really does show how novel this technology is in the field of generating solar energy. So it's very important, but it can be very expensive, and also the time and expertise needed to basically make sure that we are protecting the right things at the right time.
So can you just tell us a bit about how the business started, what the origins of the product were, and how this all came about?
Yeah, it's a very interesting story. So our chief scientist, a guy called Dr. John Topping, he's a physicist, and it happens to be from 4 miles down the road in Seaham from our factory here today. And he is an expert in vacuum coating and has licensed some technology into the packaging sector. And a few years ago, John was looking at how normal traditional silicon panels are made. They're heavy, they're capital intensive, they're mainly made in China. He said there's got to be a better way. So John used all of his toolbox from his previous experiences and came up with this concept of using microstructures. So John had the original idea, but needed some investment behind the business. So through a series of introductions up here in the northeast, I guess the northeast is quite a lot of people know a lot of people. So through some mutual introductions, John was introduced to myself and two of my ex-colleagues from a company called Eager, where we all worked in the northeast, and we were doing energy efficiency and renewables. And we knew a lot about the commerciality, but nothing about the science. And we thought that if this technology that John had developed is half as good as he said it's going to be, then wow, this could make a change to the world and a difference to the world. So basically that was the first investment that came into Parallel to allow us to undertake the proof of science. And then since then, we've built up our investor base through the typical routes, widening that investor base. So very much a Northeast story. It's Northeast invention by a Northeast team. We've got a pilot factory here in the Northeast, and we're hoping we can have our first gigafactory here in the Northeast as well. So, so why don't we go downstairs and I can show you a little bit about how we make the solar film.
Great.
Welcome to our pilot plant. So I'm going to take you through how we manufacture the solar film. And we've got about 11,000 square feet here. We've got about 40 people in the building, and developing this completely new technology. So the first step is that we take a standard piece of plastic, and into that plastic, our unique pattern is called embossed into the film, and we'll show you some of that film now. Right. So the first part of our process is that we take a piece of plastic, and into that we have our unique pattern embossed into this, very similar to making a hologram. Right. So in each one of these patches here, there's approximately 80,000 individual microstructures, so significantly smaller than a human hair. Yep. And then we now take these through the next 3 steps, where we turn this into our solar film. Right. So the next step is where we use the same technology that is used in food packaging, right, to deposit various metals and electrodes into those microstructures to create the start of our solar cell. Right. So this is the machine here. So basically, this is where we're using the vacuum coating to deposit the electrodes and semiconductors on the sides of these small microstructures. Right. So effectively, we're making a positive and negative at a micro scale. So this machine was actually again built in the UK by our partner, and is used in many other sectors, food packaging and electronics, and we're using it using a very significant amount of know-how to create our unique pattern. So this is a roll of film that's come through this vacuum coating machine, and that means that we've created the positive and negative, and the next step is that we print in the solar ink, and that turns this roll of plastic into a roll of energy. Right. So this is our third step. So we've now deposited the electrodes. So what we do in this machine here is that we print the solar ink. Right. So we're using a solar ink called perovskites, which is an emerging material in the solar sector. Right. And we do this with this machine where we are printing the ink into the microstructures, and then we're drying it, and then the second part of our machine is where we encapsulate it to provide durability and lifetime, and to give it a product lifetime of somewhere between 10 and 15 years. So this is an example of our printed solar film. So this has gone through all of the 3 steps we've looked at so far. This one hasn't yet been encapsulated, and then the next job for us will be to encapsulate that in our lamination machine. Right. And so that's a layer of plastic to protect from the elements. Correct. Yes, it's to keep oxygen and moisture out, and to provide some durability. And then the next thing we do is we'll analyze and look at what we've made and understand how we can improve it further. So we've got one of our parts of our area where we look at quality control and analysis. So we're looking through a microscope here and seeing an image. Can you just talk to us about what this is showing? I can. So this is a very powerful microscope looking down on the microstructures. So you see the microstructures coming down vertically there, and then heading across there, that's actually a human hair. Oh, wow. So what it does is it illustrates the really, really small size of the microstructures we're working with, and why it's important that we have a very clean environment and are able to manufacture in such a way. So this is where we start to look at how we might use our product in the real world. So you can see up here, we've got 3 different types of roofing installation. So this is the same roofing that's on our building up here, so a typical roof profile. You've got an asphalt system, and then for more of the developing world, you've got a corrugated roof system. And then we're looking at off-grid, powering off-grid applications. So this is obviously a small example, but we have a project ongoing where we're looking to put our solar roll on the top of trucks, right, which is to you'll not run the truck from the solar panels, but you can manage the air conditioning in the cab, maybe the refrigeration in the back, right, And then we get off-grid, so things like this. So this is water pumping. So this is a small water pump that you would have in the likes of India and Africa. And basically our solar film can be used to power this solar pump. And obviously having something that's lightweight, portable, flexible, makes it easier for the farmer to move from field to field. So this is our, starting of the potential of where the products could go in the world. But obviously this is just a small element of what we're trying to do.
Thank you very much for your time today, Neil. It's been really exciting to hear all about the product and your future plans. So thanks.
Thank you. Yeah, thank you for your time.